Okay, for chapter 5, click this one. Yes, also you can put the sorry, um, the textbooks. Yeah, from the textbook you can see chapter 5 is talking about discrete probability distribution. Okay, so basic of probability distribution is I think you know what is the difference between discrete and continuous, right? Discrete data can only be on the value of in a range, okay, and continuous data can take on any value in a range. And discrete usually arise from counting, while continuous data usually arise from measuring, right? Remember that? Okay. So how tall is a plant given a new fertilizer? This is continuous, right? And this is something you measure. Yeah, so continuous is something being measured, right? And how many fleas are on prairie dogs in a colony? So this is discrete because this is something that you can count, right? Okay. And remember you have a, what is it called, a random variable. So probability associated with variable, we call it a random variable. Okay. And probability distribution is assignment of probability to values of random variable, right? And usually using the PDF. PDF is good. You use the probability distribution function. Okay. So there are so there is a only so we can call probability distribution if they have two conditions here. The first one is the number should be the probability should be from 0 to 1, and the sum of the probability should be equal to 1. Okay, and this is the example for the probability distribution based on the US census. Okay, for example, the size of household 1, the probability is like 26 point something. Yeah. And for the size of 2, 31.6%, something like that, and so on, right? And so X here is the number of people in the household. This is a discrete random variable because you are counting the number of people in the household, right? Okay. And also this one is a distribution, probability distribution because you have the X value and the probabilities that go with it. All the probabilities are between 0 and 1, right? You can see this is from 0 from 1. You change it to decimal. For this one, you have 0.267. This one is 0.336. This one is 0.158. This one 0.137, and so on. Right? And this one like 0.063. Right? This one is 0.024. This one is 0.015. Right? Okay. So if you add this together, you got 100% or you got 1. So it's considered as, and the sum of the probability is 1. Right? So this is considered as the probability distribution. So there are two properties. One is the probability between 0 and 1, and the summation equal to 1. Okay. And you also graph the distribution for the probability. Okay. So based on this data, the probability is like this. Okay. You can see this is like, okay, skewed right? Because the tail is good to right. Okay. And this important property here, if you want to find what is the expected value, the mean or the expected value, or mu equal to the summation of x times p. And for the variance, sigma square equal to the summation of x minus mu square times px. Okay. And then the standard deviation is simply like the square root of the variance. Right? Yeah, for example, this one here. You go back to the previous example, right? So to find the mean is simply you multiply this. I mean, this two, and so on, and then add it together, you got the mean. Yeah, I will give you the Excel for this one. You can see the p times x, you got the one on the bottom here. If you add together, you got this one. Okay. So this is you're looking for the mean or the expected value. And for to find the variance, you need to subtract the x with the mu and square it and multiply with the px. Okay, you got the one on the bottom here. So if you add this together, if you add these values together, you get the variance. And to find the standard deviation, you simply just take the square root of this number. Okay. Okay. Yeah, see, this is the example if you want to use the calculator. Okay. If you want to use R program, then you need to put the x first and then put the p, and then you need to put like weighted mean and x comma p, and you got the output here. Okay. So this is for the mean. Okay. There's another example here. This is called the rare event rule for the inferential statistics. So you can read the question. Okay. And yeah, I think this only just okay. So this talking about unusual and usual. Okay, so yeah, I think you need to understand it. Okay, so this is a event of inferential statistics. If under given assumption the probability of a particular observable event is extremely small, then you can conclude that the assumption is probably not correct. Okay. And if you determine if the event is unusual, something like that. Okay. If you are looking at a value of x for a discrete variable, and the p, the property of the variable, has a value of x or more, and that is less than 0.05, then you can consider the x an unusual high value. Okay. So yeah, if the probability is less than 0.05, so you consider the event is unusual. Yeah, you will find it in the problem in MyOpenMath. What else I need to know? Yeah, for example, like this one, because it's less than 5%, then 6 is unusual high value. Okay, so let me see, what is a 5.2? So this is a 5.2 is called a binomial probability distribution. So the property of the binomial uh, experiment or binary trial, one is a fixed number of trial. So you have a fixed number of trial, which means that the experiment is repeated a specific number of times. Okay. And two, the end trial is independent, which means that what happened on one trial does not influence the outcome of the other trials. Okay. And the third one is there are only two outcomes, which call a success and a failure. And the fourth property is the probability of a success doesn't change from trial to trial, where P equal to probability of success and Q the probability of failure, or Q equal to P minus P, 1 minus P. Okay. So uh, this is the example. Yeah, so binomial probability come up often in real life. Right? For example, toss a fair coin 10 times and find the probability of getting two heads, something like that. Okay. And question 20 people in class and look for the probability of more than half being woman. Right? Because in the class you only have the probability, right? Woman or female or male. Right? Also, you can shoot 5 arrows at a target and find the probability of hitting it 5 times. Okay. Uh, so there are four properties for the binomial distribution. Okay. So you have a fixed trial, and you have a independent trial, and you have two outcomes, right? Only two possible outcomes. And the fourth one is probability of success uh, is it that should be? I mean, the probability of success doesn't change from trial to trial. Okay, okay, so yeah, so I think this will you will find in the problem. So what is the probability of getting two questions right? Uh, how many questions here? Yes, there is a correlation with this one, right? So suppose you are given three questions, multiple choices, multiple choice test, right? Each each question has 4 response and only one is correct. Yeah. Suppose you find the probability that you can just guess at the answer and get two questions right. Teachers do this all the time when they make up a multiple choice test to see if student can still pass without studying. Okay. In most cases, the student can't. To help with the idea that you are going to guess, suppose the test is in Martian. Okay. Uh, okay, so what is the random variable here? So X is the number of correct answer. Okay. And what is the binomial experiment? Okay. How many trials you have? Because you have three questions, so the number of trials will be three, right? And getting the first question right has no effect on getting the second or third question right. So, so the trial are independent. Okay. So either you got the question right or you got it wrong. So there are only two outcomes, right or wrong. So in this case, the success is getting the question right. Okay. And the probability of getting right question is 1 out of 4. Right? So that means this is the same for every trial, since this question has 4 responses. Right? Okay. So this is the probability will be 1/4. I mean the probability for the to get the correct answer will be 1/4, and the probability to get the wrong answer will be 1 subtract with 1/4. You got 3/4. Now what is the question? Now the question is what is the probability to getting two questions right? And first you need to put what is the sample space, right? So if you have 4 possible answers and then you have 3 questions, so the possibility to get the 3 questions right and then 2 questions right, 2 questions right also, right? 2 questions right, 2 questions right. I mean, and then 1 question right, 1 question right, 1 question right, and then all is wrong. Okay. So if you're looking for what is the probability to get 2 right answer, so that means you need to multiply the. So to get the right answer is only how many? Uh, 3, right? So to answer this one will be you need to put what is the probability to get the correct answer twice, right? So 1/4 times 1/4 times 3/4, right? Okay. So this will be the probability to get the right answer for from the 3 questions. Okay. Okay, so you want to find what is the to get the correct answer, so you need to add all of this together. So this we call it the binomial distribution. So here's another example how to find to get 0 right, 1 right, 2 right, and 3 right. Okay. Okay, so yeah, I think this is from here. Okay, so yeah, because you have like this is the same, right? So you can multiply 3 and then multiply by this. Okay? And yeah, for 0 right, you only have 1. Okay, so that's why you multiply by 1 here. And for 1 right, you got 3. 3 of this, so you got 3 multiplied by 3 here. And for 2 right, you got 3 also for this one. That's why multiply by 3. And for the 3 right, you only have 1. Okay, so that's why you multiply by this. Okay? Because for 3 right, you only have like 3, 1/4 to the power of 3 times 3/4 to the power of 0, right? So there's not that. So that's why you put 1 here. Uh, what else? Yeah, so this is the formula for the binomial distribution. Okay, but in this case, we will use what is Excel. Okay, to find the solution. Okay. Uh, okay, filtering. Yeah, yeah, we can use Excel to find this solution. Okay. So for example, like still looking for less than 2, you need to add probability x equal to 0, probability x equal to 1, and probability x equal to 2. Okay. So also you can, if you're looking for what at least 4 have green eyes. So at least that means it's greater than or equal to 4, right? So it's the same thing as you subtract 1 with the probability of x less than 3. Okay. Less than or equal to 3. Uh, yeah, so this is if you want to use calculator, and you want to use calculator. Yeah, all of this using calculator. Okay. So in this, so we will use Excel. Okay. But it's up to you if you want to use calculator. Okay. But I give you the Excel template to solve the problem in chapter 5. Okay. Uh, yeah, I think that's all for chapter 5. We only have like 2 sessions. I think. Let's see. Oh, we have 3. Okay. Oh yeah, just repeating the one that we have up there. Right? The mean is the summation of the x times px. For the variance is uh, yeah, 2 summation of x minus mu square plus px, I mean times px, and the standard deviation is simply like the square root of the variance. Okay. Yeah, so I think you will have this problem here. So for example, like you're looking for okay, yeah, you can draw this diagram. If you want to find the mean, you simply like multiply the yeah, if you're looking for the mean, so you just multiply the number of trial with the probability, right, equal 0.2. Okay. Yeah, I think that's for chapter 3. Okay. I mean, sorry, chapter 5. Okay. So let's go to the homework. Okay. So yeah, so also you can use the Excel. Okay, let's see. Excel for chapter 5, right? Let's see. Oh, I already downloaded it. Um, yeah, okay, I see that one. Okay, so I already download the Excel there. Okay. Hold on. So okay, can you always remember, you need to click the enable editing something like that, so in order to use the Excel. Okay. Uh, and let me do. Yeah, and also I can use the Google Spreadsheet. Okay, maybe if you don't have the Excel, you can use the Google Spreadsheet. Actually, if you don't have Excel, you can go to JCC web portal. You can download it from the Microsoft website. I think for Java student is free. Okay, let me go to the problem here. Okay. So determine whether this table represents probability distribution. Remember what is the probability distribution? You have two properties, right? So the summation of the px has to be equal to 1. Okay. And you can see also px is between 0 and 1, right? So this status, let me check if this is equal to 1 if you add this piece. Okay. Uh, if you add this to what you get, 0.25, right? And then 0.25 plus this is 8, right? So that means
It's 1.05.
yeah, 1.05. So the answer is this is not probability distribution because it's not exactly equal to 1, right? Okay. Okay. So the next question will be this one here. Find the mean of this probability distribution. Round your answer to one decimal place. Okay, let me use the Excel. Okay. Yeah, you need to change this. Okay, I need to go to question number 2, right? Question number 2 is looking for the mean. Okay. So you need to replace this number with the number in the problem. Okay. So the number in the problem, this one is equal to 0. You can copy paste. Okay. Let's see. Let me show you. You can always copy paste this number. Not always some. You can try to copy paste this number. Okay. Otherwise, you just need to put it manually. Okay. Okay. Click here. Or can click paste, right? Or you can use Control P, and you got this number here. So to get over this thing here, you need to click that one and then enter. Okay. So you can see the answer here. Okay. So you can see 0 times 0.33, I mean 0 times 0.3, you got 0, right? And then 1 times 0.05, you got this one. 2 times 0.01, you got 0.1, right? I'm sorry, 2 times 0.05, you got 0.1. And then 3 times 0.6, you got 1.8. Okay. If you add all of this together, if you add all of this value together, you got this number. Okay. So this is the mean. Okay. So the answer in your question will be, the answer for your question will be 0.95. Right?
0.95.
Yeah, 1.95. Let me put that. Okay. So the answer is 1.95. Okay, let's see. What is wrong? Okay, find the mean distribution of random. Oh, okay. So you need to round up to one decimal place, right? So if you round up to one decimal place, you got 2.0, right? Okay. Okay, so now you got the answer. Okay. So you have to remember this. Round your answer to one decimal place. So if you have if you got 1.95, so if you round up to one decimal place, become 2.0, right? Okay. And the next one, question number 3. Find the standard distribution, give the answer to at least two decimal places. Okay, so you can copy this and then put in your Excel, right? For number 3. Okay, click this one here. Just right click there or click paste it. Okay. It looks like you cannot copy this. Okay, let me try again. Okay, still cannot do it. Okay. So I think I need to go back there, or maybe just simply replace this number with the number in the problem, right? So the first number is the probability for x equal to 0 is 0.05, okay, in your problem. And then you have 0.25, and you have 0.05, and you have 0.65. Remember the table that I showed you before in the online textbook? First is looking for what is the mean, right? Or the mu, okay? And the mu is simply x times px and then add it together, right? Okay, you got this one. This is the mu, okay? And then looking for what is the x minus mu square. Okay, so this is the formula here. I already put the formula there. Okay, so you can see here I subtract a2, which is this one, with the mu. Mu is c6, right? Okay, so all of this I subtract with c6 and then take the square. Okay, okay. And then for this one, I put the so for this one is yeah, actually you use r is easier. Okay, but I think you can use this one. Okay, you can use Excel. Okay. So you can see you multiply d2 is x minus mu square. Okay, times the px is p2, right? And the same thing for this one, and this one. And the summation of this one is we got the variance. Okay. And in order to find the standard deviation, you just take the square root of the variance, which is square root of E6, because the E6 is the variance. Okay. So your answer, you can copy this, okay, and go to your problem, and then right click, paste it there. Or you cannot. Okay, so you can use Control V. Okay. Now you run that to, okay, give your answer to at least 2 decimal place. Okay, so if they ask you like, I mean, if the question asks you like this, at least 2 decimal places, which you just can copy and paste it and then submit it. Okay, so you don't need to run that because it's at least 2 decimal place, right? Okay. Okay. So you just copy and paste it because they said here at least 2 decimal place. So that means if you put more than 2 decimal place will be okay, right? You can see this is okay, right? Okay. Let's go to the question number 4. Okay. Can the following table be a probability distribution? Okay. Remember what is there are two, right? Condition, right? So the summation has to be equal to 1 and the probability between 0 and 1. So I think, so this is between 0 and 1, right? Now you need to check whether the summation is equal to 1. Okay. Let me see if you can use the Excel here. Okay, let me go back to the Excel. Oh, maybe I need to copy first. Okay, hold on. Yeah, I need to
So
copy
the
first.
sum has to be equal to 1, or it could be like from 0 to 1.
There are two conditions. One is between 0 and 1, and the summation of the px has to be equal to 1. Okay.
Okay.
So now let me put in the Excel and see what is the summation of this. Okay, number 4, right? Let me put it here, right click, paste it. Yeah, it is work. Okay, so sometimes it doesn't work. It does work. Okay. So you can see the summation is less than 1. Not equally, it's not exactly the same equal to 1, right? So the answer for this one will be no.
It's not, right?
Yeah, no, yeah. So the answer will be no. Okay. And question number 5. Yeah, the same thing. You can copy this and paste it to the Excel for number 5, right? Number 5, this one here. Put it here, right click. Yeah, this is for yes. Otherwise, you have to copy one by one. Okay. So the question here is, what is the probability for x equal to 6 and the probability for x less than 6? Okay. For x equal to 6 will be this one here. Okay. So equal to 0.0054. And in looking for less than 6, so you need to add from 0 to 6. Okay. So in this question here, you need to change to, so the summation will be from 0 to 6 is the same as you add P2 to P8. Okay. Okay. So you have to add P2 to P8 because P2 is x equal to 0 and P8 is x equal to 6. Okay. So your answer will be this one here. So you can copy this and then paste it to your answer. Okay. Okay, so for x equal to 6, the answer will be 0.0054. Okay. You can see this one here. And for less than 6, so you need to copy paste from the Excel. So this is the answer.
So then if it's less than 6, you just add all of them from the top, right? Till
Yes,
6.
from the top up to 6, yes.
Okay.
And it didn't say anything about the rounding to decimal places, something like that. So you just need to copy and paste it there and then submit it. Okay. But now you need to be careful. Remember what is just the yeah. So this is talking about if the trial is fair or not. Okay. Or what discriminate the Mexican American hammer. Okay. So because this is less than 0.05, so the conclusion will be yes. Okay. Remember the from the chapter, let's see, yeah. Unusual that means it's not usual, right? So that means it's discriminate against American Mexican, right? Yeah, I will say this the one that said it. Yeah, what is if the fair or not. Yeah. Should be this one. Yeah. I think the end of section 2. Right here. Okay, for if the probability is less than 0.05, then you can consider this is unusually low value or unusually, anything that is not fair, something like that. Okay. So in this case, the answer is uh, yes. Okay. So the process is discriminates against Mexican American. Okay. Yeah, maybe this is like one of the example in criminal justice, maybe, right? The application of the statistic in criminal justice, maybe. Okay, for the next one will be this one here. If the seed is planted, it has a 70% chance of growing into a healthy plant. Okay, if a seed is planted, it has 70% chance of growing into a healthy plant. Okay. Now, if 11 seeds are planted, what is the probability that exactly one doesn't grow? One doesn't grow. So that means this is like the opposite, right? So that means you need to find what is the probability, like the seed that is growing into the unhealthy plant. Okay. So that means the probability will be 0.3 instead of 0.7. Okay. So you can use the Excel here. So you have 11 seeds. And what is the probability exactly one doesn't grow? So I will show you how to use the Excel here. This is for question number 6. Right? Yeah, this one is a little bit tricky, so you have to be careful. Okay. Yeah, so exactly one doesn't grow. That means you need to put this one is 1. Okay. And how many seeds? 11 seeds, right? And the probability will be 30%. So this one 0.03. Okay. Sorry, 0.3, not 0.03. 0.3. Because it's 30%, right? And you had to put false because you're looking for exactly. Okay. If you put true, that means it's cumulative. Okay. But in this case, it's exactly, so you have to put false there. Okay. So this will be answer. You can copy and paste it there. Okay. Okay, so copy and paste it and submit it. Okay. Yeah, so you need to put the probability at 0.3 because you're looking for the opposite, right? The plant that doesn't grow or the unhealthy plant.
So can you go back to the Excel so I can see how you input it, please?
Yeah. Okay, let me go back to Excel. Okay. Yeah, maybe I need to change this. Okay, let's see. Let me put the question there. Okay. Okay, let's see. I want to put the question there so you can see it. Okay. Oops. Right. Okay, I think I need to put one more space there. Okay. It will not override that one. Yeah, so this is a tricky question here. Okay, so they give you the healthy plan percentage, but you're looking for what is the plant that doesn't grow. That means the plant is not unhealthy, right? Okay, so this is a binomial distribution, right? And you need to use this formula here. So you're looking for what is the probability exactly 1, so you put 1 there, right? Okay. If you, for example, like what is the probability exactly 2, something like that, you need to put 2 there. If you have 4, you put 4 there, okay? And the 11 will be the number of trial or the number of the seeds.
So it's first the number, like what they're asking, which is one
Yes.
doesn't grow, and then it's how many total, and then it's the percent, and then we
Yes.
put false since they're
False.
asking. Okay, I got that one.
Yeah, because false is because you asking exactly. So for example, like looking asking about less than, so you need to put true.
Okay, thanks.
Yeah. Okay. Uh, yeah, good. So you don't need to. Okay, so yeah, maybe I need to put this one also. Put it down here. And then I can erase that one. So this for number 7, right? So let's go to problem for number 7. Okay. So equal, that means exactly 6. Okay. So using the binomial distribution, so you can do the same thing. Okay. So let me copy this. And then put in the Excel. Okay. Yeah, I want to get rid of that thing. Okay. So in the binomial distribution, as you can see here. So the first number should be the x. Okay. So this should be the x. The x is equal to 6. Okay. And then the number of trial, the n is 6 also. So don't worry about that. Okay. Sometimes the problem like this. Okay. And then the probability is 0.05, so you don't need to change that one. This is exactly, so you put false. Okay. So this will be answer. Okay. So you can copy and paste it. Let's have it. Okay, so the next one. Yeah, it is the same thing. Okay, so so there is nothing that is strange here. Okay, so for number 8. Oh, sorry. Yeah. Sorry. Let's go back to the problem first, right? Yeah, for number 6, number 7, right? So number 7 is, yeah, will be the same thing as number 7. Okay. So you have the x, you have the n, you have the p, right? And then because exactly, so you put true. I mean, to put false. Okay. Okay, for this one, the probability will be 40% or 0.4, and the x is 6, the n is 10, and put the probability, right? And then put false because you're looking for exactly. Okay, so okay, this number 7. Yeah, you need to get rid of that blinking stuff. Okay, so put it there and then enter. And now you can go here. So in this problem, the probability is 45, right? That's why you put 0.55 here. And how many exactly? Exactly at 3, so you put 3 here. And what is the total? Total is 5, so you put 5. Right? And our problem here, you have 46 and 10, right? So you need to put it here. Six 10, and 40% will be 0.4, right? Okay, and I put false because you're looking for exactly 6 out of 10 people. Okay, so this will be your probability. You can copy and paste it there. Okay, and okay, so this one is a little bit different. Okay, so can you see the problem here? So for this problem, this is the probability, right? Okay, so at least one will have defect. Okay, at least one, that means it's greater than or equal to 1, right? So, so in this case, you need to use a cumulative distribution. Okay? Let me see. You have 3% and you have at least one. The atom is 3, right? So now you want to do in Excel, you can see the example percent Excel maybe. Okay, so number 9, this will be this one. Okay, let me go back to number. You need to put, you put it back there and enter to get rid of that thinking stuff. Okay. So, so you can see here, if you have 7% defect, so you need to put 0.07, right? Okay. And how many is the total? So total 10 items, so you put 10 here, and at least one, so you put 0 here. So this is like this. For probability for at least one to practice or greater than equal to 1, okay, sorry. Okay, on. Yeah, I think I make mistake. I think, I don't know, maybe somebody it is changes. Okay, so this one should be greater than equal to 1. Okay, so the probability of greater than equal to 1 is the same as the probability of, sorry, 0 subtract from 1. Okay, you know, instead of you add the probability like from 0, I mean from 1 to 10, so you can do is you can subtract 1 from, you can start you can subtract 1 with the probability of x equal to 0. Okay, so does that make sense?
Yes.
Okay, so in your problem you still have 0 here, but now you need to change the total is 3 because you have 3 atoms, right? And then the probability will be 0.03, and you have to put true because you're looking for the probability, cumulative probability, so I have to put true. Okay. But maybe that, okay, you can also think about, because it's 0 is only 1, so you cannot have less than 0. So maybe, so if you put this false also will be give you the correct answer. Okay, because actually x is I mean x equal to 0 is only 1, right? So the collector is cumulative or exactly, so you will get the same answer. Okay. So this is the answer. So you need to put this in the Excel. Okay. I mean in the answer box in MyOpenMath. Okay. So you can copy and paste it here. Okay. Control V. Just get that number. Okay. So now For question number 10. Yeah, so for this case, you're looking for the mean, right? So just simply multiply the n. I mean, the n is 800 people, right? And then the probability is, or the p is 3%. So you simply multiply 0.03 with 100. Sorry, 800. So you will get what is this here? This for number 10. Okay, so you need to go to number. You need to go to number 10. So you just simply. Okay, so exactly you have the same thing here, 3%. So you can put as if you don't need to replace that one. But in the problem you have 100. Sorry, 800 people, right? So you need to change this about 800. Okay? So 0.03 times 800, you will get about 24. Okay? So your answer will be 24. Okay, you can submit it. Yeah, again, it's just simply like the P 0.03 times 800, you got 24. Okay? Okay, for number 11. For number 11, looking for the standard deviation. Okay. You simply multiply the n times q, I mean, n times p times q, and then take the square root. So I will show you in Excel how to do it. 11. So just replace and take the square root, right? So how many people? 100 people, right? So the n is just 100, and the p is 3%. So the q will be the same, 0.97, because if you have 3% or if you have 0.03, so if the p is 0.0, if the p is 0.03, so the q will be 1 subtract with 0.03, so you got 0.97, right? Okay. Yeah, put the formula here. Okay. So let's see what is the answer. So this will be answer. Okay. And you can copy and then paste it to your answer. Yes, okay. What is the next one? How many more do you have? Oh, okay. You have 16 questions. Okay. Okay, let me see. Okay, for this one, when taking 11 question multiple choice test, where each question has 4 possible answers, it will be unusual to get one. So this is the way to calculate it. Okay. Let me show you in Excel. Four possible answers, 11 questions. Okay. So for number 12, yes, up to 15. So now you're in number 12. Okay. So it's simply like change this. So it is like looking for the opposite. Okay. So you know the probability. I mean, yeah, you know the probability, and then you know the number. Now you need looking for what is the x. Okay. So in your problem, how many questions you have? 11 questions, right? And the probability will be 1/4 because you have 4 possible answers. Okay. So you can leave this alone. Okay. And then you put enter. So the unusual answer will be 6. Okay. Okay. So in this case, if you, for example, if you put the one in the Excel is got wrong, so you need to reduce or you need to increase. Okay. Okay, for number 13, yeah, this is the one in the example also in the textbook, right? Okay, let me show you using the Excel here. Okay, let me go back to the problem first. Okay. So the problem is you have multiple choice questions, each have 3 possible answers, and one of which is correct, right? Assume that you guess the answer to for such questions. Okay. Use the multiplication rule to find the probability that the first 3 guesses are wrong and the fourth is correct. Okay. So this like you can put like this. Okay. So the 3 guesses wrong and then the fourth guess is the last one is correct. Okay. So what is the probability? Uh, so you need to find. Okay, sorry. Oops. Yeah, you need to go back to the Excel. Right? Okay. For number 13. Okay. So in here, how many possible answers you have? 3, right? So for the 3 possible answers, so the correct answer will be 1/3, right? And the wrong answer will be you subtract from 1 with so if you subtract 1/3 from 1, you got 2/3, right? And how many wrong answer? Yeah, apparently you have 3 wrong answers, so you have to put 2 to the power of 3, right? Yeah. Okay, so and then enter. So this will be answer for that one, for number 1. Okay. You can copy and paste it for question number 1. Okay, so you need to round up to 4 decimal places. Okay, so if you round up to 4 decimal places, so you will have up here 1, 2, 3, 4. This one should be 8, right? Okay, so and then if you guess correctly for cases, exactly 1 correct answer with 4 cases. So this one you need to use a binomial distribution. So in Excel you can do like this. Okay. So for your problem, it's remember the probability is 1/3, right? Because you have 4 possible answers. Okay. I mean, you have 3 possible answers, okay. And you have 4 questions. So you're looking for exactly 1 question right. So this will be the formula to find the probability. It's on the probability distribution, right? I mean, binomial distribution. So this will be answer. Copy and then paste it to your question there. Okay. I mean, your answering that. So now you need to round up to 4 decimal place. Okay. Okay, so 0.3951, right? Yeah, I think this one should be your answer. So this one should be the answer. Okay, here I go. Okay, so the next one. Okay, for this one, yeah, again, you can use the Excel here. So in this case, your P is 0.679, okay. So in the Excel, you need to change, so you need to change the P here, which 0.679, right? So 0.679, okay, enter. Okay, so looking for the rest, you simply copy from the first one, okay. You can, did you see the small, I don't know what I call it, plus or cross, okay, so small plus sign over there, I mean, so you need to hold it and drag it down, okay. So this automatically will copy the rest, okay. You can see there's a change now the quality to 0.679. This one also 0.679 also. This is the same thing, right? 0.679. Yeah. This I put false because you're looking for exactly x equal to k. Okay, so the k is on the left here. So this for x equal to 0, px equal to 1, px equal to 2, px equal to 3, 4, 5. Okay. So you can copy this one by one. Paste it here. Oops, sorry. Let's move off here. First enter first, copy, and paste it to answer. Go back to the Excel again, copy, oh sorry. Okay, so then that one, this one, right? Copy, and paste it here. Copy, paste it here. Copy, paste it here. Okay, copy, and paste it here. You can submit it. Okay, so good. All the correct answer, right? Right. Okay. So the next one will be this one. So this one, but this one is less than or equal to k. K is 0, 1, 2, 3, up to 5, right? Okay, so now you need to change this to the Excel, and the property you have is 546, right? 0.546. Okay. So number 15. Oops. What did I see? Oh, I think somebody clicked it. Okay. Okay, so we need to change this one is 546. 0.546. So we just need to replace the 2 with 6, right? Okay. And also you need to change this to true because you don't have we have a cumulative probability, right? You can click this one, yeah. Click twice, okay. Enter. And do the same thing. Put it back there. And put over it the cursor until you see the small cross there, and then hold it and drag it down, right? So automatically will copy for the rest. Okay, so you can see it's 0.546, 0.546, 0.546, 0.546, and 0.546. And the total has to be equal to 1. Okay. Remember, one of the conditions for the probability distribution, the summation of the probability for the probability has to be equal to 1. Okay. So now you do the same thing, copy, paste it. Copy and paste it here. Copy and paste it. Copy. And paste it here. Copy. And paste it here, right? And the last one is a 1. They just put like 1, 0, 0, 0, 0. So you can submit it now, right? Yeah, the last one is 1.000. So just type it there. So now you can submit it. Okay. So this is the correct answer. Okay, what is the last one here? Okay, so the last one is a little bit longer, right? But don't worry, you have the Excel, okay? So this is the problem is also the same thing as is like the binomial distribution, okay? Or the Bernoulli trial distribution. A study was conducted to determine whether there are significant difference between medical students admitted through special program such as retention intensive and guaranteed placement program and medical student admitted through the regular admission criteria. It was found that the graduation rate was 92.2% for the medical student admitted through the special program. Be sure to enter at least 4 digits of accuracy of this problem. So what do you think? I think the problem is like any equation, but the equation for medical student, right? Medical school, something like that. Okay. Okay. So the first problem is if 11 of students from the special program are randomly selected, find the probability that at least 10 of them graduated. Okay, so just simply using the Excel here. Okay, let me show you. Yeah, it's just the same words, okay, but the different number maybe, right? Okay, so in this case, so you need to change this the one here, okay, the Excel command here. So you need to change this one, okay. I said at least, okay, hold on. What is the question? Find the probability that at least 10 of them graduated, okay. Oops, sorry. Sorry. So at least 10 of them graduated. So I mean, if say at least is the same as what? Greater than equal to 10, right? Okay, so the problem is the same, right? You have 11 students and you're looking for at least 10 of them graduated. So the same thing, right? But the probability is different, okay? So the probability in the problem is 92.2%. So you need to change this one to 0.92. 90, sorry. You need to change to 0.922, right? Because if you have a 92%, 92.2%, so you can change to 0.922, right? And this is true because it's cumulative, right? So you need to subtract from 1. Okay, so this will be answer. So you have to be careful here, okay? So to answer the question at least 10, so you need to subtract from, no, not at least, yes, at least 10 or at least 10 or greater than equal to 10. So you need to do as a 1 equal to subtract with at least, I mean, less than 9, okay? Less than n equal to 9. Okay. So you will get this answer, okay? And the next question is, so yeah, maybe I can put this as the answer first before we move to the next one. So this one will be, because it's at least 4 digits, so you can copy paste, okay? So don't worry about that. I think it will be no problem, okay? So the next one is a probability exactly 8 of them graduated, okay? So they need to put it here. So this one is exactly 8, so the same thing, okay? But different is the probability is different, okay? So you need to change this one to 0.922, right? Yeah, exactly 8. So you can put 8 there and then 11 because the total student is 11, and then the probability is 0.992. This is false because you're looking for exactly, okay? So you need to put false. Okay, okay, so because you can put at least 4 digits, so you can copy all of them and then put it here. Okay. Oh, missed the one part here. Okay, sorry. So would be unusual to randomly select 11 students from special exactly 8 of them graduate. Yeah, the answer is unusual because it's less than 0.05, right? And now you can for this one here. At most, okay, at most that means is less than 8, less than equal to 8. Okay, so you need to go to the Excel. Oops, sorry. Yeah, so this one exactly, I mean, at most that means it's greater than, I mean, at most that means it's less than and equal to n. Okay, so again, so just need to change this the probability. So the probability will be 0.992. Sorry, 922. So that will be the answer. You can copy and then paste it to your answer in MyOpenMath. Okay. This is unusual because your answer is 0. Less than 0.05, right? Less than 0.05. Okay. Okay, so yeah, at most this one at most, right? Because it's less than, sorry, at most this one. Okay. At most this one, and would it be unusual to randomly select 11 students from special program and get only 8 that graduate? Yes, you can see. Yeah, so from special program and only 8 graduate. So this one exactly, right? Needs to be exactly is yeah, I think the answer is also yes. Okay. Okay. So any questions so far? I think that's all, right? So we have like
That's
16
the
questions.
last question.
Yeah, okay.